All right, so today we're going to learn another use of matrices. They're just such a great way to organize information, organize numbers. And one of the places in math that we just power through numbers everywhere is dealing with systems of equations. So I'm going to show you a way that you can use what we call an augmented matrix to solve a system of equations, sort of still doing what you're familiar with on your elimination idea. But what we do is we just like ditch all the variables. Let's just power through the numbers of it, and then we'll put the variables back in at the end. Okay, so augmented matrices. Again, this is a great method that works when numbers don't play out nice, pretty whole number answers all the time. All right, so let's talk through some things. First of all, an augmented matrix. An augmented matrix is a matrix that's derived from a system of linear equations. And so here's the system. This is what we were doing like day one with this chapter. We were solving this system. Now, I've always kind of given you problems where the answers come out relatively reasonable, and you don't have to battle fractions. But this is a method that can kind of battle the fractions for you. So we've got an augmented matrix where you take your coefficients from all your variables and you create this nice 3 by 3. This happens to be a 3-variable system. It can work with 4 variables, 5 variables. I take the constants and I put them over here, but notice that I've put like this bar in this one. That sort of is replacing those equal signs. So we sort of are keeping the coefficients, the variable parts, separate from the constants. This is what we would consider the coefficient matrix. It's just this piece of the augmented matrix. Now we're still going to do the same things that we would with elimination, but what we're going to do is we're going to leave the X, Y, and Z out of it. So we have to kind of keep track of the numbers that we're dealing with. So here are some rules or some operations that we can do. We can trade around 2 rows if we want to. There are benefits sometimes to trading rows. Now, whatever you do, you have to indicate with some sort of a notation. Like I said, this might be a 4-variable system. We really need to be organized. So if you're going to swap 2 rows, you would say something like this. Row A, which usually is going to be like a 1 or 2, row 1 and row 2, I'm swapping them, something like that. You can also multiply a row by some sort of a constant. If you're going to do that, then you'd say, oh, I'm taking this constant times row A, which really is, again, going to be like, I'm going to take 4 times row 2, something like that. You can also add a multiple of another row. So that's really, this is going to be the one we do the most, to be honest. We're going to take some constant times one of the rows and add it to the other row. That's sort of that whole idea that you do in elimination to get one of the variables to eliminate. We still do it here. Now, I cannot emphasize this enough. So much so, I am incredibly picky about this. So those of you that love all that mental math and are kind of sloppy with your work, today is not your day. The math that we are going to do is simple addition, multiplication, very basic arithmetic. But we're going to try to be efficient with it, and we're going to be completing multiple steps in one that we have to show very, very organized work. It happens all the time that we get sloppy and we make these little mistakes, and then we get frustrated. So I don't want you to be frustrated. I want this to play out nice, and it will, because we're going to show nice, pretty, organized work. And we're going to use this proper notation so that when you raise your hand and you have a question, I can track what you've done because I can see this nice notation. Oh, you took this row times 4. I see what you did here. You've got to use that proper notation. First of all, let's look and see if you can tell what I'm doing to a particular matrix. So here's my matrix. Let's look at the new, we call it the row equivalent matrix. It's equivalent, but it's changed. Now, row 1 did not change, and row 3 did not change. But row 2 is different. So if I changed row 2, then I have to have a rule out in front of row 2 that tells me what I did. And so my hint to you is I somehow combined this row with one of these other rows to try to eliminate it. Okay, so look at what my goal was, to turn this 3 into a 0. So then the trick is, if you were thinking like system of equations, what could I do? What would I try to do to try to get that to turn into a 0? Well, looking at my options here, I'm probably going to match it with row 1. And if I was matching it with row 1, in my mind, I would take 3 times the row 1. And to be honest, I'd really do a negative 3 times row 1. And I would add it to row 2. Now, I'm just going to write it. I might be wrong. I'll come back and change it. But in my mind, I'm thinking if I were doing it, I would take negative 3 times row 1, and I'm going to add it to row 2. This right here is the part I'm saying, got to be super clean, neat handwriting that I can follow. Now, if that was really going to be the rule, then I have to do it for every term. So a negative 3 times 1 plus the 3, there's your 0. Let's see if it works for the other. If I take a negative 3 times 0, that's 0, plus row 2, plus 1. It gets me a 1. Negative 3 times 2, that'd be a negative 6. I'm sorry, negative 3 times row 1, that's a negative 6, plus the row 2, so plus 7. That would get me a positive 1. Boom, got it. That's right. This is the rule that I would use to make this happen. Now, I really like this row a lot better than this row, because you can see the 0 and the 1s. Those are going to be much nicer to work with. That's going to be our goal today. Now, this is called Gauss-Jordan. These are both mathematicians that work together to come up with this way of working with augmented matrices. And it's called reduced row echelon form. So row echelon form is this idea of writing these rows of your coefficients and your constants, turning them into this matrix. But the row echelon form, the reduced row echelon form, really wants to have lots of 1s and 0s in here, because 1s would be like a 1 on an x. Here, remember, these are just going to be the coefficients. I'm forgetting about the x's and the y's, and I'm just writing the coefficient. So you can see, here's your linear system. This is a 1. This coefficient is a negative 2. This coefficient is a 3. And the constant is a 9. And so that's all we've done, is we've taken this linear system and written the augmented matrix. And I want to get my augmented matrix into this reduced row echelon form. Reduced row echelon form would have a 1 here with 2 zeros. A 1, so it'd be a 1x, and the y and the z would be gone. And then whatever it equaled, well, that's what my answer would be. Oh, x must be whatever that number was. And then in this row, I would want these to be zeros, and I'd want this to be a 1. So that would mean I'd have a 1y equals whatever would happen to be over here at that time. And then in the last one, I'd want 0, 0, 1, so that I'd have a 1z equals this. And then I would end up knowing what x, y, and z equal. All right, that's the goal. Now, I feel like I've said that's the goal several times here today, but here's the goal. Here's my reduced row echelon form. Like I said, if I can get this to have these 1s and 0s, then I have determined that this would be my x equals 1, my y would equal 2, and my z would equal 3. That's what I would want to have happen. So our goal then is to get this reduced row echelon form, and here's kind of how we do it. We're going to work left to right on each column. So I'm going to start with this column here. And what I really want to get are the zeros in the proper location. Don't worry about the 1s yet. Our focus is going to be the zeros to start with. And then, so I'm going to work on this column. I'm going to make these be zeros. I'm going to work on this column, make these be zeros. Work on this column and make these be zeros. And every time it's that same way. These two, then these two. That's going to get your X, your Y, and your Z to happen. Now, once you have your zeros, then you'll divide as you need to turn these into a 1. So if this happens to be a 5, well, I would just divide the whole row by 5. And that would turn that into a 1, and it would affect what the answer is there. I'm going to start with just a 2 by 2. I'm not sure this is the most efficient way to do a 2 by 2, but let's just start with little baby steps here. So here's what I'm going to have. I'm going to turn this into this augmented matrix, and I'm going to write just the coefficients. Be very neat. Keep nice spaces in here. This coefficient's a 1, a 2, and a 13. Remember that you draw a line here to indicate that's your equal sign. You didn't need to make that really bold like that, like I did, but that's what it looks like. Now, I'm going to give you a template to help with doing these because there's certain things that are common mistakes, and sometimes having that template I find helps avoid those mistakes. When you're taking this original system and you're just turning it into the augmented matrix, that's fine. There it is. There's not really anything to do on that. But now I'm ready to make changes. And so if I'm going to make a change, remember my goal here is to get this in reduced row echelon form. Now this is just a 2 by 2, so there's not as much going on. Reduced row echelon would look like this on a 2 by 2. And I say 2 by 2, it's the coefficients that I'm looking at that's going to be this reduced row echelon. So it's going to be that. And then whatever you get over here, I just write A and B, whatever those numbers end up being. But this right here is what I'm shooting to have happen. So I start with this, and now I'm ready to make changes. So I need, according to what I said, is I want to work on this first column, and I want to make that be a 0. So I am not going to do anything to, oops, I'm going to go back to red here. I am not going to do anything to the top equation. So I'm going to rewrite it. I am going to make changes on the second row. So I'm going to put a line here. And this goes on the line where you're making the change. You would not put this up here and then make the change down here. The line indicates the change that is happening right after it. So the change I'm going to make is I want this to be a 0. So sort of thinking back to how we do systems of equations, how would I get that to turn into a 0? Well, I'm going to need this to be a -2 so that it'll combine. So here's what my rule is, and the rule is part of the answer I'm looking for. I am going to take my row 1, and I am going to subtract 2 times row 2. So let's look at how that would play out. Row 1, that's a 2, minus 2 times 1, which is 2. So 2 minus 2, there's my 0 that I'm getting from that. I got to do it all the way through. Row 1 minus 2 times row 2. So that's going to be a -3 minus 4. That's a -7. And then the last one, -2 minus 2 times 13, that's 26. So -2 minus 26. That's a -28. So again, I wrote that in blue so that you understand that wherever you write the rule, that is where the line is changing. Not on the next matrix, not on the one before it, on that very matrix. Okay, looky, I got my 0 that I wanted. Now my next job would be to turn this into a 0. So to turn this into a 0, I've got to somehow combine it with row 2 so that those will cancel out. Now look at that. That's not going to play out very nice, but it's very doable. I know that I could make them each be 21s. One's positive, one's negative. But I am going to say that, yes, I'm going to work on my zeros, but I also don't need to make my life miserable here. I can see right here that these would both divide beautifully by a -7, and it would get my numbers a lot smaller and easier to work with. So on that slide earlier that kind of said, here are the different things that you're allowed to do. One of the things that we can do is we can multiply a row by a single number. In this case, I'm going to be dividing by that row. So here I go. I am going to make a change again on the second row. So I leave the first row alone. There's no shortcuts in this, not as we're getting started here. Shortcuts come after we're experts. We're not experts yet. I am going to change this row right here. So I am going to just take that whole row and I'm going to divide it by -7. So this is what I'd write. Row 2, divide by -7. 0 divided by -7 is still 0. -7 divided by -7 is 1. And -28 divided by -7 is a 4. All right, so I feel like that was going to be worth my efforts, worth rewriting that to get my next step, because really I'm trying to get this to be a 0. So now working with a 1 here instead of a -7, that's going to be much nicer. All right, like I said, I'm going to give you a nice template that will help us with this so that it's not going to be as messy as what this is going to be. All right, so here I go. Oops, I'm going to undo that because I want to leave space to draw a rule line out in front. Now, I'm working on this row now, turning this into a 0. So I'm going to leave the bottom row alone. I'll rewrite my bottom row. Not changing that at all. But I am going to work on my top row. So that's where my rule is going to go. So I'm going to write the line out to the front, and I'm going to put my rule, and I've got to think about what would I need to do to turn this into the 0. Well, I need that to be a 3 right there. Then I could add them together. So I'm going to take 3 times row 2 and add it to row 1. That's the rule that I write out here. 3 times row 2, add it to row 1. All right, so let's see what's going to happen to this row. 3 row 2 plus row 1. Well, that's just going to be a 2. 3 row 2, it's a 3, plus a -3. There's the 0 I wanted. All right, let's see what happens with our numbers. 3 row 2, so that's a 12, plus -2. That's a 10. Okay, now I've got my zeros. Now I work on getting the ones. Looky, I already have the 1. I already took the effort earlier to do that just so to get my numbers nicer, but I need this to be a 1. So what I need to do is take this whole row and divide it by 2. So last step, I'm changing the top row. The bottom row is good to go. Write your rule out in front. I'm changing this row. I'm taking row 1 and I'm going to divide it by 2. So this is going to end up being a 1. That's still a 0. And 10 divided by 2 is a 5. When you get it to this stage right here, you have determined, remember that the first column are your x's. So a 1x is going to equal 5. The second column are your y's. So this is a 1y is equal to 4. We have our solution. It's an ordered pair, 5, 4. And that's your solution. Now, that took me about 18 times longer than it would have if I was just doing substitution or elimination. I get it. Remember, we're just getting started here. We're going to get better. We're going to get faster. It's going to work out nicer. Let's try a 3 by 3. Those don't take a short time. Now, again, we're still learning this. This is going to be a little bit of work here, a 3 by 3. I definitely have a template for us on this, though, to help us get started. The first thing we're going to do is we're going to write this as a matrix, as an augmented matrix, and get rid of the x's and y's. And then I'm going to work on getting those zeros and those ones. I'm looking for this row echelon form to happen. And I do my my column by column a lot more consistently on this version. This is what I'm going to be shooting for. Column by column. Get the zeros and then come back and get the ones. The only reason that I would get a 1 earlier is if it's going to help me to like simplify after that. Sometimes I'll do a little quickie divide by to get my numbers smaller. Let's use the template on the next page to do this problem. Now, my template is not ideal on the slideshow. On the template I give you in class, it is going to be a straight vertical. I am going to do this, I'm going to do this, I'm going to do this. I'm going to work downward instead of this crazy up, down, up, down. It was the only way I could fit it into this slide. But you need to kind of see the full problem on one slide. So, first step, you're going to rewrite the matrix in this augmented matrix format. Notice on the first matrix, I have no lines. There are no rules that go on the first matrix. You just write it. So putting in our coefficients. All right, I may not change colors quite as often on this one. I'm going to just go blue. Let's see what happens here. All right, I've got a 1. Looking at the previous page at my coefficients. And then these are my constants. Now, this isn't a whole lot of work. You can see I don't have a whole lot going on here to solve a 3-variable system. This is going to be kind of good because what I'm going to do is I'm going to get efficient here. And I'm going to work on multiple rows at the same time. And I'm actually going to do the same thing every time. That's why there's a template. The first thing I want to do is I want to work on this first column. And I got lucky. This is already a 1. It may stay a 1. It may not. I don't really care. What I really want to do is turn this into a 0, and I want to turn this into a 0. That's why I have lines here and here, because I'm going to be working on row 2, and I'm going to work on row 3. And I've got to match them in some way. Now, the one thing you're not allowed to do, and if I remember there's a problem on the homework that is very tempting to do this, I cannot write a rule here that uses the exact 2 rows that this one does. Like I can't combine row 2 and 3 and then do the same thing row 2 and 3 here. Otherwise, they kind of are undoing each other and they sort of cancel everything out. That doesn't work. You've got to pick different rows. So I am going to, what jumps out at me is I'm going to group this with row 1 right off the bat. That looks the easiest to me. So I'm going to take row 1 and row 2 and I'm going to add them together. I am also a fan of always writing whatever row you're working on is what you write last in your rule. So I'm going to write row 1 and I'm going to add row 2 because I'm working on row 2. Now again, I am not changing row 1. I might as well just put those numbers in there now. And then you're always referencing back to the previous matrix when you're doing your rule. So row 1 plus row 2. I'm always referencing up here, back to the one before it. Add these together. Oh, this is going to go fast. Add those together. Add these together. Add these together. Add these together. See how fast this is? It's going to go great. It's going to be fun. Okay. Now I need to work on getting this to be a 0. I can group it with, I haven't used row 3 for anything yet, so I can group it with this one. I can also group it with that one. I don't know, this one's already negative, so I kind of like that. So since I'm working with row 3, I'm going to write row 3 at the end. So I'm going to do 2 row 1, nope, I'm not, 2 row 2 plus row 3. Now, this takes a little bit more mental math because I'm doing a multiplication at the same time as an addition. This is this kind of mental math here. Now, I say mental math. You can use a scientific calculator if you want. On the test, you'll only have a scientific calculator available to you. So if that's what you're doing, maybe practice with that instead of your graphing. But so 2 times this, so that's going to be a negative 2 plus row 3, so that's going to be a 0. That's what our goal was. All right, next. 2 times this, so that's 6 plus negative 5. 2 times this, that's 0 plus 5. 2 times negative 4, so that's negative 8 and 17. That's a 9. Okay? After you get the first column, now you're going to work on your second column. Remember, in the second column, you want this one and this one to be zeros. So notice where my rules are, top and bottom. I am not going to change the second row. Maybe go ahead and just write the second row. I am not going to make any changes on it. But I need this to be a 0. So I've got to come up with a rule. I've got to group this with one of these two. Doesn't matter which, it looks like it's the same deal. So I'm just going to group it with row 2. So I am going to say, let's see, I need to take 2 times row 2, and I'm going to add it to row 1. 2, row 2, plus row 1. 2 times 0, plus 1. 2 times 1, plus negative 2. 2 times 3, that's a 6, plus 3, that's a 9. 2 times 5 is 10, plus 9 is 19. Okay, that doesn't feel very pretty, but it's all right. It's going to play out okay. All right. Now I'm going to work on row 3, and I need, this time I'm trying to turn this into a 0. I already have a 0 here. I don't want to lose that. That's one thing to note here, is that that's why you go left to right. And you have to be careful about what you group it with, that you don't end up losing a 0 that you've already created. For instance, if I were to group this row 3, let's say I group it with row 1, because I'm trying to maybe make this be a 0 here. But if I group it with row 1, somehow that 1 is going to mess up my existing 0. So don't do that. You really don't have an option here. You have to group it with row 2 so that you don't mess up the 0 you already have. So I'm going to have to group these two together, which is okay. That's going to be ideal anyway, right? So I'm going to do a row 2 minus a row 1. I'm sorry, minus a row 3. That's what I'm going to do. Row 2 minus row 3. Now, there is more than one way to solve these. I'm giving you some hints along the way to make good choices, but we may not all do this the same way, which makes these rules exceptionally important for me to track your work, because I have to grade everybody's matrix step by step by step. And if I'm struggling to read your handwriting or to follow what you're doing, I just can't spend 15 minutes grading one person's matrix. So keep that in mind. Here I go. 0, 0 minus 0. 1 minus 1. 3 minus 5. 5 minus 9. All right, that worked out well. Now I'm ready to work on these two and turn these into zeros. Now I can start to see that this is not, these are going to group nicely. They're not going to group great with this 2. I'm trying to get these to be zeros. I feel like I'm going to have to group them with row 3 so that I don't mess up, I don't mess up the zeros here that I already have. For instance, if I were to try to group these two together, this 1 is going to mess up that 0. Or maybe that 1's going to mess up that 0. So on this last one, you're always going to be grouping it with that third row, because that third row now has 2 zeros in it. Now, here is my one cheat. This is the one cheat I let you do. The one. I don't like messy matrices. You don't get to do a lot of erasing and scribbling and simplifying and changing out stuff. But here's the one thing with a 1 clean, and if you did it with a different color, you'd be my favorite student. But here's what I'm going to do. I'm going to do a quickie. divide row 3 by -2. Look at what's going to happen. If I do row 3 divide by -2, without rewriting this whole entire matrix, mostly because I'm out of space, I'm going to divide that. It's going to turn into a 1, and that's going to turn into a 2. That is the one cheat I'm going to let us do, because that's going to make this combination with the other rows a lot cleaner. And if I'm feeling nice, I'm not going to give you terrible answers, even though that's sort of the point of doing this, is it can power through fractions really nicely because you don't really deal with them until the very end. But I'm still probably not going to give you terrible fractions. I mean, this is the first time you've seen it. So I'm going to let us cheat a little bit. And now I'm going to come up with a rule to turn this 9 into a 0. And I'm going to group it with row 3. And look, since my row 3 is now a 1, that's going to work good. I'm going to say -9 times row 3 and add it to row 1. Again, remember, I like to end with the row I'm working on. So whatever you're messing with, do it at the front and then finish with whatever row. All right, so here I go. -9 times 0 plus the 1. -9 times 0 plus the 0. -9 times 1, that's a -9 plus a 9. There's that 0 I wanted. All right, and now really we're getting to the constants. That's what I'm really interested in, seeing what plays out here. This is a -9 times 2. That's -18 plus 19. Oh, that came out really nice. That's just 1. Okie doke. Now let's work on this row 2. Row 2 needs this 3. Oops, didn't mean to do that. Needs this 3 to be a 0. So again, I'm going to group it here so that I don't lose the existing 0. I'm going to group it with row 3. Looks like I need to take this times -3. So I'm going to do this. -3 row 3, add it to my row 2. I'm going to get a 0. And taking this times -3, adding row 2, still going to be a 1 there. -3 times 1, that's a -3 plus a 3. There's my 0 I wanted. Let's see what happens with our constants. -3 times 2, that's a -6 plus 5. It's a -1. And then I'm not making any changes really to that third row because I already did my little cheat there. And I got lucky here. I already got the 1s. I didn't even have to worry about turning those into 1s. They played out nicely. I didn't have to do like this last step of division or something. I've got my answer. This is the solution to the system. 1, -1, 2. All right, once you get the hang of it, it works pretty slick. Just, again, be super neat, be careful. It's the little details that mess you up. Otherwise, it works pretty slick. Okay, I'm going to try one more of these with you. Again, that process is going to be the same, so I have a template for us. Same template. The first matrix is always us just turning the system into an augmented matrix. So let's go ahead and fill that in. This is coming up from that previous slide. Okay, now what I'm going to do is I am going to leave the first row alone. Nothing, I could try to turn that into a 1 or something, but nothing's going to divide by 3 nicely. I don't want to end up with fractions. I'm trying to avoid those. So now what my goal is to turn this into a 0 and this into a 0. So I've got to group these in some way. I don't know, the -5 None of them are going to group nice, right? Nothing's perfect there. Great. Let's work on how we deal with that. It's the same with a system. Let's say I'm going to group. I'm thinking I'm going to group this row 2 and row 3. I'm going to group these and turn this into a 0. So what I want to do here is think when you're doing systems and you're doing elimination that I need these to both be 10s, but I want one of them to be positive and one to be negative. And I kind of like that there's one of each right now. So I'm going to make this be a positive 10 and this be a negative 10. And then when I add them together, this will turn into a 0. All right, so here's how I'm going to write that. I'm going to go ahead and remember how I like to write the rule. I like to write whatever I'm changing row 2. So I write something row 2. My row 2 is here. So I'm going to say 5 row 3 plus 2 row 2. All right, so if I do that, now I'm kind of looking at 5 times 2 plus 2 times negative 5. Well, those are going to cancel out to 10 and negative 10. That was the whole goal. Okay, but I got to do it all the way across. So this is going to end up being negative 10 plus 6. That's a negative 4. Then I'm going to have a negative 15 and a negative 10. That's negative 25. And then the last one, 5 times 15. Well, I know that's 75. And then 2 times negative 8, that's a negative 16. So 75 minus 16 is going to be a 59. Now, when you start getting to this point, you might be going to your calculator just to confirm things. So don't be afraid to do that when we start getting big numbers like this. Okay, so I've got my 0. Now I'm ready to work on this row. And again, I need this to be a 0. I cannot use row 3 and 2 again. So that means I'm forced to use my row 1. So I'm looking at row 3 and row 1. I'm going to want those to be 6s. One's a positive 6, one's going to be a negative 6. So the way I'm going to write this is I'm going to say 2 times row 1. That's going to make that be a negative 6. Plus 3, row 3, and that's going to be a positive 6, and that's going to get my 0. All right, but let's do it all the way down. So 2 row 1, that's a 14. 3 row 3, that's going to be a negative 6. So 14 and negative 6, that's 9. Okay, that is not 9, that is 8, sorry. Next, I'm going to see those are the kinds of mistakes you can't make. You can't make those silly mistakes like that. 2 times row 1, so that's a 4. And that's going to be a negative 9. 4 and negative 9 is going to get me a negative 5. And let's do it one more time. 2 times row 1, that's a 2. Plus 45, that's a 47. Okay, we're going to get some messy numbers, and that's okay. If I were doing this with elimination and did the whole thing on the 3-variable system, I'd be getting these same ugly numbers. Okay, now I am ready to move on to the next column. I need in this second column, remember I didn't write this, but I probably should have somewhere just so that you kind of remember what we're looking for. We want that to look like this. 1 0 0 0 1 0 and 0 0 1. That's the method we're looking for. So I've already got my 2 zeros here. I'm going to this column. I need to make this a 0 and this a 0. Looky, I already have the 2 lines because I know I'm going to be working on row 1 and row 3. That's the whole point of the template, is because I've got it set up. It works the same every time. I am not going to be messing with row 2 on this one, so I'm going to go ahead and just rewrite the row 2. Somehow, I am going to have to turn this 7 right here into a 0. Now, nothing really is going to multiply great here. I guess I'm just going to work with the 4. It's a little bit smaller. So I'm going to make these both be 28s. This is going to be a positive 28. This is going to be a negative 28. And that's how they're going to cancel out. So that means that when I write my rule here, I'm going to end up taking a 7 times row 2. I'm going to add a 4 times row 1. Let's see how that plays out. So 7 times row 2. And as you're doing this, you write the rule right where you're making the change. But you're always referencing the matrix before that as you're doing it. So here I go. 7 row 2, that's a negative, let's start with this one. That's going to be a 0. That's going to turn into a negative 12. And it's okay. I don't really care so much about that number. I'm just working on those zeros. Now I'm going to do 7 times negative 4. That's negative 28. And that's going to turn into a positive 28. There's that 0 that I want. Let's do it again. I'm going to do 7 times negative 25. All right, I think it's time to get my calculator out. So 7 times negative 25. And then what you're going to do is you're going to add 4 times row 1. So 4 times 2, that's an 8. So I'm just going to add 8 to that. And my answer is negative 167. All right, that's all right. Don't be afraid of it. It's fine. All right, next, I'm going to do it on the constants. So 7 row 2, 7 times 59. Go into my calculator. Don't know that one in my head. And then I'm going to be adding 4 times row 1. So that's just plus 4. All right, I got a 417. All right, now we're going to do it again. We're going to work on this 0 right here. So it's going to go here. Now, it is worth noting here that you start to catch on that I really don't have options. Probably about from here on, my option days are done because I cannot group row 3 with row 1 because this 1 here would mess up the 0 I've already created. So I am forced to work with row 2 so that those zeros don't hurt each other. And so you can't be backtracking and losing the zeros you already gained. To get this, and it's this 8 right here that I'm working on, trying to turn this into a 0. Well, that's going to match really nicely there. I'm just going to do a 2 row 2 and add it to my row 3. So there's my rule. 2 row 2, add it to row 3. 2 row 2, add it to row 3. Those are just zeros. Nothing's going to happen there. 2 row 2, add it to row 3. There's that 0 I wanted. Okay, now let's see what we get here. 2 row 2, so that's going to be a negative 50 plus row 3. So negative 50 with a negative 5 is going to be a negative 55. All right, one more time. Negative 2 times 59, go into my calculator, plus the 47. And I have a 165. Now, right here is about the time where I start to make some decisions on if I'm on the right track or not. Now, remember, the point that we're doing this is because it's a great way to deal with matrices that have pretty messy fraction kind of answers. But since it's day 1, I'm choosing not to give you those types just to kind of practice so you get familiar with how to do it. But ultimately, what I would be doing right here on row 3, I'm going to want that to be a 1. So I would take this whole row 3 and I would divide by negative 55. And I want you to kind of do that right here. This is the one cheat that I let you do where you get to divide by negative 55. That's going to be a 1 because what I want to know is I want to know that this divides nicely. And it does. It divides very nicely. That just ends up being a negative 3 right there. If that didn't come out nice, that would be your hint to, hey, you better go backtrack some stuff and see if you goofed up somewhere. Because I want this to kind of come out nice as we're first learning this. And that's going to make my next 2 rules really nice to have a 1 right here instead of a negative 55. Last matrix. I'm working on these two zeros here. I will have to group, and back to what I said, you're running out of options. You will have to group with row 3 because row 3 is the one that has these zeros, so it's not going to mess up the zeros you already have if I had numbers. For instance, this 1 would goof up that 0. So I am tied on both of these to group with row 3, which is totally fine. I would have chosen to do that anyway. For the first row, I want this negative 167 to go away. So I am going to have to take row 3 times 167 and add it to row 1. When I do that, I know that my first one is going to stay a negative 12. Then I'm going to add zeros, and then I'm going to get a 0. That all plays out. That's the whole point. But let's check this last number. It's going to be a negative 100, or I'm sorry, a positive 167 times a negative 3. And then I'm going to add 417. And I get negative 84. So for as ugly as that was, 84 here is actually nice. Here's another place you might do a quick mental check. Is that going to divide by negative 12 nicely? And yes, it is going to divide by negative 12 nicely. So I think I'm on the right track. Let's do one more. I am working on this 0 here. I want this negative 25 to be a 0. So that means I'm going to take row 3 times 25, add it to row 2, and the first one's going to be zeros. 25 times 0 plus the negative 4, that's just a negative 4. Then I'm going to have a 25 and a negative 25. There's my 0. Here's a 25 times negative 3. That's negative 75. And then I'm going to add row 2, so plus 59. And I end up with a negative 16. What do you think of that negative 16? Do you like it? You should, because it's going to divide nicely by negative 4. Okay, and then on my last one, I got 0, 0, 1, negative 3. Now we could take a whole nother step, but I'm out of room, and so I'm going to let you do your final step is just to write your ordered triple, and ultimately you're going to divide by whatever you need to make this be a 1. So if I divide that whole row by negative 12, that's going to turn into a positive 7. On the second row, I'm going to divide by negative 4. That's going to turn my answer into a 4. And then the last one is already there. It's a negative 3. And there's my ordered triple. And I've got it figured out. See, it's kind of fun, isn't it? Yeah, I know you want to say it. Good luck. Don't make silly mistakes.